Good afternoon, everybody. My name is Kevin Fay, and I'm a contracts director with GEM Group. Basically, I'll be speaking today on adapting to the challenges of Part L and upskilling as a main contractor, the challenges of working with subcontractors, defects, whether there may be a failure of expertise or a commitment maybe on behalf of the contractor or maybe the design team as a whole, and then working with new construction technologies. As a main contractor, and literally I'm a firm believer that in order for the requirements of Part L to be achieved on site, it involves the collective participation of all parties involved at the outset, from the design team, the main contractor and their subcontractors. It requires an understanding of the regulations of how they apply to the particular project in question. It requires that the appropriate products and material specifications are prescribed and installed in the correct locations and to the highest standards. Only then will we achieve low-energy buildings that will meet the demands of the future and help to ensure the preservation of our green environment. Adapting to Part L, and how as a company that we maybe met the challenges of upskilling. In 2008, the board of GEM recognised that with the introduction of new regulations, we need to formulate and roll out across the company a plan with procedures to allow Part L to be understood, adopted, implemented into practice. And we saw this maybe happening in 4 parts. Initially, there was off-site tutorials, there was on-site demonstrations, air permeability testing and quality control. For the off-site tutorials, we engaged the services of Ecological Building Systems, who I think actually are exhibiting here today, to present a number of in-house seminars to all our construction staff, directors, managers, engineers and foremen. We also arranged for a number of key on-site personnel to be further trained at their Centre of Knowledge training facility. The main focus of the training was to gain a better understanding of what was being asked for by the new building regulations and how to achieve these regulations on site. Particular focus was centred on cold bridging, air tightness, air pressure testing and permeability. Initially, our staff were trained with Proclama, a suite of products, but since then we have also been inducted and trained in the SIGA range of installation of products. Ecological Building Systems also provided on-site demonstrations and a number of our initial projects from their trained supervisors. They periodically called and inspected elements of the work as they proceeded and inspected each detail to ensure compliance with the recommended manufacturer's details. This approach proved to be reasonably successful with our first project, a 6,000 square foot cavity block wall constructed private dwelling over 4 floors, achieving an air permeability value of less than 3. At the outset, we recognised the importance of thermal bridging and air tightness details and their execution on site in achieving a low-energy building. With this in mind, we purchased our own WinCon air tightness quality control unit to allow us to carry out our own blower door testing at an early stage of the project. Selected on-site supervisors were trained in setting up and using the WinCon apparatus to ensure accurate results. This assists us in identifying potential leaks in the external fabric of the building at first fixed stage. Any leaks were inspected, resealed and then tested and carried out until a satisfactory result was attained. And I think going forward, I think thermal imaging will be something that we will add to our collective tool. And I think something as main contractors, I think themselves are going to have to engage with, and actually some of the tools are going to have to be used in the future. Some of the main reasons maybe for establishing a better air tightness will include reducing energy consumption due to air leakage, avoiding moisture condensation problems and avoiding uncomfortable drafts caused by cold air leaking in from the outside. The final stage that we undertook to try and compliance in relation was quality or control procedures. This was in 3 parts and involved working in conjunction with the design team in question as follows. I think it's important that we need to establish or define the actual air tightness line of a building or a particular project. This is normally straightforward for floors and walls, but can sometimes prove more problematic at roof and ceiling junctions. Define the main construction perimeter locations like floor wall junctions, window jamb and head details, roof and wall junctions, and agreeing service routes and penetrations through the external fabric of the building. And 3, then preparing a check sheet for typical junction detail locations that can be inspected and checked on site by appropriate personnel to ensure that best practice in this regard and air tightness. This is a typical sheet which we ourselves have kind of implemented. This was for one of the first houses that we had done. It was a cavity block wall construction, 100mm external leaf, 110mm cavity, 60mm insulation. It had a 215 solid block internal wall, dry lined internally with 50mm insulation. It also had the window reveals were also insulated. It had cavity closers, and literally, so we used this particular sheet on site to ensure that literally the various elements were actually installed correctly and checked at various stages during the project. I mean, there's certain elements in relation to the air tightness members to make sure that you were getting a seal between the parge coat, which I'm not quite sure if you can see there. There's a parge coat applied to the internal face of the 9-inch block wall before the dry lining was put on, to ensure that all the surfaces were kept in a complete zone and not penetrating or as little as possible through the external envelope. That parge coat then was actually sealed to the timber windows, and then externally the plaster seal came in with DPC, and it was also sealed with a vertical sealant. But it's just a typical detail that literally, and the level that we've tried to go to in trying to achieve quality control on site. In relation then to item number 3, above guidance was taken then for sustainable energy document, limiting thermal bridging and air infiltration, accepted construction details, which is literally where we try to base this particular sheet on. Then the challenges then with, I suppose there's not much point in maybe one person on site or maybe the contractor understanding what needs to be done, but working with subcontractors is a challenge in itself. And I think there needs to be a better understanding by subcontractors in the main of actually working on low energy buildings. In order to achieve the standards required for low energy buildings, it is essential that all subcontractors and their operators working in site are made aware of the targets to be reached and maintained during the course of the project, right through to practical completion. With the complexity of the modern building envelope, it is essential that consideration is given to achieving insulation continuity and airtightness from the outset. As with health and safety practices, awareness on site is paramount to achieving low energy. All operators working in site are inducted prior to commencement with regard to health and safety rules and regulations governing a particular project. So we feel that maybe it's an opportunity, and it's not diminishing from health and safety, but literally when people are being inducted on site, that there's an opportunity there to make them aware of what you're trying to achieve on site in terms of a low energy building and literally the drawings and details that we're trying to work towards. The responsibility of ensuring best practice is maintained on site with subcontractors lies directly with site management. The role, in my view, is to review all details appropriate to the various disciplines and trades and make certain that the design team's drawings details are not compromised, especially in relation to the external envelope. All subcontractors should be issued with a full set of details which clearly identifies the air barriers and insulation lines. It's important that they understand that this line cannot be breached during the course of their works, and that if such management and if it does, that management should be made aware of this and ensure that the appropriate remedial action is taken by a suitably trained person. All buildings have penetrations which are unavoidable, mostly due to services either entering or leaving the building. But with proper planning and detailing, such penetrations can be sealed with a number of proprietary materials and methods. Problems mostly arise at a later stage if breaches of air barrier lines are not made known and overlooked. In this regard, a zero tolerance needs to be adopted from the beginning by site management. In addition to breaches of the air barrier, insulations can be dislodged, can be from their intended position, damaged or even removed. One method which we have implemented to try and overcome these difficulties with our site management is to snag works as works proceed. And personally, I'm a great believer of that. I believe that literally, if a building is snagged and checked as it's proceeding, there's no point waiting until the end of a building project and then we'll snag the building or we'll check the building. I think it's very important that as a building progresses to the various design stages, that it actually is checked and snagged. And I see that being as much a role for site manager, but also for the actual design team, that they themselves, I think, if they're going to be signing off on a building, I think they, for their own maybe peace of mind, that that the buildings are checked maybe at critical stages during the course of a project. And I think maybe more so with the new regulations, that before walls are closed up at first fix stage, there's a good opportunity to actually to have a look at exactly what's going on behind what will be eventually closed up. The sequencing of subcontractors and their works is critical to the success of any building project, and even more so with low energy buildings. Site management need to ensure that construction programmes are consistent with regard to effective formulation of air barriers and insulation lines, I think this was mentioned this morning previously that construction programs maybe had been changed to accommodate maybe the forms of building that we're actually now being asked to achieve. If scheduled correctly, the possibility of interruption of these lines will be greatly reduced. We've also then introduced toolbox talks on site to our subcontractors during the course as other contractors come on board to try and assist in getting better buildings. At GEM, we feel only when all of the above items are integrated into the day-to-day activities of construction projects, being communicated from the design team through to site management, can Part L of the building regulations be truly achieved. This is the minimum standard that should be sought by all in delivering low energy buildings. And just going on very quickly, I think we're short on time. It's just defects then, a failure of expertise or commitment. As noted at the outset, the successful delivery of construction projects, and in particular a low energy building, involves the collective participation of all disciplines. The relationship between the main contractor and the design team is critical in achieving this end. We at GEM are committed to working hand in hand with project design teams in achieving all aspects of the project brief from the beginning. We believe that this mindset is the blueprint of any successful project. Defects can and do occur in building projects, and with the higher demand of improved thermal bridging and air tightness to achieve low energy buildings, it is important to recognise and understand that from the outset these can occur. It is equally as important to have the ability to overcome these if and when and if they arise, both at design stage, estimating, and at the construction stage. Some defects, in my opinion, occur before a project reaches a site at design stage, while others are a direct result of on-site activities. They can include literally poor or underdeveloped details which do not reflect the work to be carried out, materials or performance specifications, buildability, cost evaluation, lack of communication between the designers and the contractor, poor workmanship or poor quality control. With low energy buildings, it is essential that the design team's intention of how they want the building to be constructed is clearly set out on the construction drawings and specifications. With low energy buildings, the level of detailing in relation to cold bridging and air tightness significantly increases and involves comprehensive working plans, sections and large-scale details. However, as contractors, we feel that only the standard details are well developed, and that other junction locations, which are equally as important to project success, are sometimes laxed or even omitted. We feel that there needs to be a greater emphasis on detailing between the architect and the services consultant. Dedicated service routes need to be defined at the outset by the M&E consultants in conjunction with the architect. This is in particular true when it comes to dealing with service penetrations to the external envelope of the building, floors, walls and roof locations. For some reason, the detailing and responsibility of these locations would appear to rest with the contractor, but in my opinion, this should not be the case, and a more collective approach, I think, on projects going forward is a better way to move. If all service penetrations are clearly defined at the outset in relation to their location, size and how they integrate into the architect's detailed external envelope, then a detail can and should be presented which demonstrates how this service can be successfully dealt with regard to cold bridging and air tightness. Such detailing would, in my opinion, greatly improve the chances of success on site. Very, very quickly then, the selection, I suppose just maybe then, I suppose wrapping up with maybe, in my opinion, more work needs to be carried out collectively by the industry as a whole to ensure that better buildings are produced. This starts with the design and quantity evaluation of projects and follow right through to the quality control to be achieved on site. Good quality contractors have, in my opinion, not interfere with better regulation in this regard, and I, as a principal at GEM, would welcome such moves in this direction. Defects, a failure or commitment. I don't think there are any easy solutions to this statement. I think there is a willingness by all parties to achieve better, sustainable buildings that will comply and will exceed the expectations of Part L in the long term and their design and construction. However, how we get there will depend most part on the parties involved and on the individuals' roles and responsibilities. Just very quickly moving towards the end, just in conclusion. Low energy buildings are achievable if the right approach is taken from design through to construction and practical completion. With the new regulations, it is equally important that the building is controlled on completion and that the end user guide is in this regard. As contractors, there are numerous challenges in applying the regulations on construction projects, but with the proper education and understanding of what is to be achieved, and in cooperation with good construction drawings, details and specifications, I am confident that the buildings that will be constructed under Part L 2011 will achieve the desired effect of limiting the amount of energy required to operate them and the amount of CO2 used in generating this energy. Thank you very much.